Start then. Today we're going to finish up 9.3 and go over 9.4, two sample dependent. You have Connectmath 8.3 due tonight, and then on Thursday you have 9.1/9.5 due, and also lab 7 is due. On Sunday, so you have homework due on Sunday. 9.3 is due on Sunday, and the next Tuesday 9.4 is due. Also, exam 3 is 2 weeks from, no, a week from Thursday. Which means that we don't have class on November 26th. Yes?
Oh, I was raising that.
Okay. If for some reason you wanted to not take it here, and you want to take it on November 26th at 11 o'clock with my morning class, you could do that. That just means that you would not have that day off. Right? So I will be here on the 26th. So technically there will be class, but you will not miss any points for not coming. I'll just be here hanging out. So if you guys want to come over and talk about any questions you have, then I'll be here hanging out. All right. Review session is next Wednesday from 7 to 8 in 601, just like before.
Are you not having a daytime review session that day?
Not that day. It'll be the following Monday.
Got it.
Yeah. So, you've done an experiment or you've taken a survey. Now what can you do with that data? There are 3 different possibilities. One, you can do it if you don't know your mean and you want to estimate what your mean is, or you don't know your P and you want to estimate what it is, you can do that with a confidence interval. That's chapter 7, right? Estimating or making confidence intervals. Or, if you know the population's mean, and you want to know if your mean differs somehow from the population's mean, right? Like that's like our deck of cards. Remember, like the regular deck of cards would be 50% red cards, and then you guys all thought that maybe my deck had a higher number of red cards in it, higher proportion. So then you compare, you take a sample. We got 6 in a row. We thought that was unusual, so you're comparing your sample to the rest of the world's population to kind of see if your population probably differs from everybody else's. That's a hypothesis test. The last thing is, that's chapter 8. The last thing we're going to cover is going to be chapter 9. When you have 2 samples and you're going to test them to see if they are the same or different. Chapter 9. So, the null hypothesis for 2 proportions. Says, Sunny, go ahead.
The null hypothesis for 2 proportions. The null hypothesis, no difference between the 2 populations. H naught is P1 equal to P2, also written as P1 minus P2 equals 0.
Right. So in other words, null is always no difference in this case between the 2 proportions. They're the same, and if you subtract them, you get 0. Pooled sample. Remember, in other words, you have your first proportion, you have your second proportion. If you were to add them up together, all your successes over all of your attempts, that would give you your pooled proportion. If you pooled them together as one big group. Q bar is 1 minus P bar. Here again for your notes, P is the population proportion, and is your sample size, and X is your number of successes. And you guys remember that P is equal to X over N, right? And again, if you know these two, you're trying to find X, you could say that P times NP is equal to your X. You can do it that way as well. The way that this is different is the test stat. Everything else in the test is exactly the same as they have in previous tests. You have your observed value minus your expected value over the standard deviation for that sample. But remember, since P1 is supposed to equal P2, then this is just 0. These P's are not populations, they're all those P's are all proportions. So P hat 1 minus P hat 2, proportion, sample proportion 1 minus sample proportion 2. And then these other two things were the population proportions. And then here we have the P bars. They're all proportions. And since we assume that these two are the same from the null hypothesis, then this should be 0 and should go away. So you really have just this part here. Where is it on your yellow sheet?
Bottom. Bottom.
Yeah, bottom right. And you'll notice that it's slightly different here. We did P bar times 1 over N1 plus 1 over N2. Well, that's exactly the same denominator as that one. Only we've used the distributive property to pull out the P bar and put it in front instead. Otherwise, it's exactly the same. Okay, let's take a look at quiz problem number 1. So we established our null hypothesis. Or what was our claim?
P1 is less than P2.
Yeah, is less likely than P2. So our null hypothesis is always
Equal.
equal. So P1 equals P2. And H1 is our claim. P1 is less than P2. That's our claim.
Support.
So we're going to use the word support later on. If it is less than, if our claim is less than, if our H1 is less than or greater than, then it's one-tailed. If our claim is equals or not equals, then it's two-tailed. Also, the only time that our claim is H naught is when our claim is or equals. Otherwise, our claim is going to be H1. Okay, so let's take a look at step 2. What's step 2?
Critical value.
Critical value. And again, that's exactly the same as it has been in the past. I'm going to draw a little picture. Is it left-tailed or right-tailed or two-tailed?
Left tail.
Left-tailed. So shade the left, shade it in, and then is this a proportion or a mean?
Proportion.
Proportion. So we're going to use a z-table or a t-table?
Z-table.
How do you know it's a z-table?
Easy peasy.
Easy peasy. Easy peasy. Proportions, you use a z-table. So it's going to be a z-table. So then what's up with my degrees of freedom?
Not
Yeah, we don't use it.
applicable.
Use it. Degrees of freedom is infinity, right? Doesn't matter. So I'm going to bust out my little table. This is a one-tailed test. Z, bottom.
Negative.
What's my alpha? 0.05. So see where it says 0.05 significance level? That's the same thing as alpha. It's our levels of unusualness. Right, what do we consider unusual? 5% or less. That's our significance level. That's our alpha. Same thing. So I'm going to go to alpha one-tailed test, 0.05, all the way down, 1.645.
Negative.
Ah, and it's negative. Why is it negative?
It's a left tail test.
Left tail. Okay. Next, we need to figure out what's our next step?
Z test. T.
Yeah, we need to figure out our
Test.
test stat. This is our critical value. So our test stat is equal to, I'm going to go back to this little sheet here, and we've got, it's a hypothesis test and it's proportion, so I'm going to look right in here to sample. Right, everybody is right in here? Yes?
Yes.
Okay, good. So it's going to be P hat 1. See where it says Z equals, that's the test, but the top it says test stat. So top up here it says test stat. Here's another good hint. it will tell you whether it should be a Z or a T. Z table or T table from that this part here.
So
Okay,
if you write Z equals, is that wrong?
that's fine. Okay, so I need the numbers actually in there. So what's my p hat 1?
0.261.
Okay, yeah, let's find these. So p hat 1 equals 12 over 46. You said, what was it?
0.261.
And then my p hat 2 was 27 over 43, which is, what'd you get?
628.
628.
No.
And then we have our p bar, which is equal to 12 plus 27 over 46 plus 43. So what's that equal to?
0.482.
482. So then our q bar is equal to
1 minus
1 minus 0.482, which is 0.518.
0.518.
So those are all our little pieces.
I do not have those dates.
We got 0.438.
Yeah, that's 438.
438.
Is it? Sorry. I probably put it the wrong way.
Okay. That works. Okay, good deal. So I've got to pop those numbers in. 0.261 minus 0.628 over square root of, oops, uh, 438. 0.562 times 1 over 46 plus 1 over 43. And then it gets really messy, right? So instead, what I think I'm going to do is I'm going to I'm going to jump over to my calculator. And I'm going to do stat test. What am I looking for here? How many samples do I have? 2. So it's going to be 2 sample Z test, 2 sample T test, or 2 prop Z test. Which one is this?
2 prop C
2
test.
proportion, yeah, 2 prop Z test. I'm going to pop those in. My X1 is,
12.
what was it?
12.
12 out of,
46.
and the next one was what?
27.
27 out of
43.
43. And then what was my test?
Less than.
Less than. So I need to go over to less than and enter on less than, so it becomes less than. Calculate. And it gives you my Z. Z is negative 3.49. Good? When you round?
What is it?
It's right here. Z. Negative 3.49 once you round. 487. Oh, also, my p-value. Everyone see my p-value?
Yeah.
Yes.
Is my p-value 2.44?
No, it's
244%?
no, it's
Oh, no.
it has 4 zeros in front.
Yeah. Anytime you see a p-value more than 100%, more than 1,
No.
you better be looking for an e negative something. Right? So e negative 4 means you add 4 zeros to the front and put the decimal place after the first zero. Should become smaller. Okay. So 3.49, negative 3.49. Throw that in, it's somewhere out here. Yes?
Yes.
Everybody on board?
Yeah.
Okay, so why don't you guys take 30 seconds with your neighbors and figure out whether I'm going to, 15 seconds, figure out step 4. Am I going to reject or not reject? I'm going to randomly call on somebody, so check with your neighbors. I'm going to randomly pick somebody in 15 seconds and give me an answer.
Okay, so I just got something different than that.
Oh, I didn't do that. I did it for like.
Charmaine,
Oh,
am I gonna, what am I gonna, so remember, step 4 is all about H naught. Either reject it or don't reject it. What are we gonna do?
Reject
Reject H naught. Why?
because it's way beyond the unusual level, like the critical
Yeah.
value.
It's way in that unusual area. Do you guys follow that? H naught says that we are right smack dab in the middle. If you get something out here or out there, I mean, depends on what you're looking for, but if you get something way out in the shaded area, then your mean is not the same as everybody else's. And you should reject H naught. Now, if you get something unusual, you reject H naught.
Yep.
H naught says your typical, your usual. If you get something unusual, reject H naught. So we're rejecting H naught. That's step 4. Step 5 is all about your claim. So the first part of it is going to be either you are going to have enough evidence or not have enough evidence. Talk to your neighbors, 15 seconds, figure out what that first part is before I call on somebody randomly.
there's enough evidence to support the claim.
Alright, here we go. Just the evidence part. Haley! Hey, you guys, listen up. Haley says there is enough evidence. Why is there enough evidence?
That's what we are supposed to can support the claim it's guilty.
Because we're guilty. We're in this guilty area over here. We're in the shaded area. So enough evidence. Right, we're in the guilty range over here. Evidence 2. Everybody talk with your neighbors. 15 seconds, figure out what comes next. What word comes next? And why?
Because
Our claim is H1.
rejecting H naught is the supporter.
All right, here we go. Lindsay,
Yeah,
what word goes next?
support.
Support. Why?
Because your claim was H1 and you're rejecting H naught.
My claim was H1
One.
and my claim was H1, so I'm going to use the word support.
Yep.
Great. The claim
Blah 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 blah.
that, what was the claim? That
Money in larger denominations
larger denominations,
is less likely.
yeah, is spent less.
Yep.
That gets the idea across, right? Okay, so people have issues with this whole support versus reject part. First off, let me point out, step 4 is only about H naught. And it's only the word reject. You're either going to reject H naught or not reject H naught. Step 5, no H naught in here. H naught belongs in step 4, not step 5. This is all about your claim. So, if I have enough evidence, and if I rejected H naught, I have enough evidence. That comes directly from step 4. This word here depends upon what your claim is. So if we kind of look back, we talked about this before, but I'm just going to talk about it one more time. Right, so this is all about step 4. This part here is all about your claim. If H naught's your claim, you're going to use the word reject. If H1's your claim, you're going to use the word support. Always. Always, always, always. You guys remember that thing I talked about, the whole QRS thing? Right?
Yes.
Remember QRS, R for reject, S for support. Because if H naught is your claim, what comes first, H naught or H1?
H now.
H naught. So what comes first, R or S? R. So if H naught's your claim, use the word reject. What comes second? H1. What comes last? S. So if H1 is your claim, you're always going to use the word support. Always. Always, always, always. Yes?
If it was flipped, like, if you don't support it and your claim is H1, would you still use, the word
You
support?
wouldn't use the word support. Oh, if you fail to support it.
Yeah.
Then you would fail to support it. So this is why.
Okay.
Rejecting H naught. If your claim is H naught, then rejecting H naught rejects your claim. Failing to reject H naught fails to reject your claim. Doesn't support your claim, it just fails to reject it. Your claim, right, your claim might still be wrong. If your claim is H1, then rejecting H naught supports your claim. Failing to reject H naught fails to support your claim. It doesn't reject your claim. Your claim might still be right. Remember we talked about that type 2 error? If you get, if something's like 7 or 8% likely to happen, then it's not enough. If our alpha is 0.05, it's not enough evidence, but they might still be guilty, right? So you can't say that you're rejecting the claim. You just can't support the claim. It's not as strong. Anytime that you don't have enough evidence, you can't really reject or support anything, right? So you don't have enough evidence to support it. You can't reject it. So that's why you can't use the word reject. Because you're not rejecting the claim, you just can't support the claim. Rejecting is a lot stronger. But rejecting is a lot stronger than saying, well, I can't support it. Yeah?
So what's the second portion of that answer in the first and second? There is not enough evidence in the first one?
So yeah, there either is or is not enough evidence. That's the first part.
Uh-huh.
Second part is you're going to either use reject or support. If your claim is H naught, you're always going to use the word reject. Always. If your claim is H1, you're going to use the word support. Always. When is your claim H naught? When your claim is or equals. When is your claim H1? Every other case. Differs, less than, or greater than. Great.
Michelle,
Yes.
so back to the example.
Uh-huh.
For the exam,
Yes.
you, for step 3, so if you want to use a calculator, you still have to plug in the
Yes.
formula, or
This is
just
the bare
give you
minimum.
the formula?
I need this, and I need that.
Okay.
I don't need this part up here. But I do need this and that. I need the formula, the numbers in them, and I need the actual answer.
Okay.
Everybody on board?
Yes.
Okay. Great questions. Okay.
I have a question.
Yes.
Are we able to use the calculator to do it?
Absolutely.
Problem?
So yeah, so you're allowed your T-table, your yellow sheet, your half-page notes, and your calculator. TI 83 or 84 calculator. Yeah.
Will there be another section at the beginning that you're not allowed to use your calculator?
Nope. Everything here is hardcore. Boom, you're right in it. There is no warm-up. It's all, yeah.
Hardcore.
It's all, you're right in it from the beginning. Yeah.
So nice.
Yeah. And actually, it's kind of good, you know, because there isn't anything where you have to do manual calculations in that sense. Okay. Good. Why does it say quick part? Oh, because we're on the wrong sheet. That's why. Okay. I want to talk a little bit about confidence intervals.
Yes, please.
So here we're estimating the confidence interval of P1 minus P2. So you take your P hat 1 minus P hat 2, and you add or subtract your error. Where your error is equal to your Z alpha over 2. Z alpha over 2 is the same thing as what?
Z alpha. Your alpha? No, your P.
CV, critical value.
Critical
I think
value.
some people said it here, but I couldn't hear them very clearly. Yeah, that's equal to your critical value. Multiplied by
Those things.
those things, yeah. Here's the deal. I think that it is, well, we'll do an example. We'll do an example. We'll talk about it here. How about, Dennis, go ahead.
Construct a 90% confidence interval estimate of the difference between two population proportions. What does the result suggest about our claim about people spending large denominations relative to spending small denominations?
Okay, so here, we find our critical value. This is our critical value right here, right? And our critical value from our problem was 1.645, you guys remember that? And then our P hat 1 was 12 over 36. Our Q1 then would be this right here, 1 minus that. Our P hat 2 was 27 out of 43, you guys got that? So then our Q hat 1 would be, or Q hat 2 would be this. Our N1 was 46, our N2 was 43. You calculate all that, you get this number here. That's our error. Then, we subtract our P1 minus P hat 1 minus P hat 2, and a lot of you guys did that, right? And you got negative 0.367, yes? We're going to take negative 0.367, and we're going to add and subtract 0.161. You subtract it, you get negative 0.528. You add it, you get negative 0.206. That means that we expect that if we subtract those two proportions, we're going to get a negative number. Right? Zero is not included, it's going to be all negative. Which means that we expect that P1 is less smaller than P2, totally. Because when you subtract them, you get a negative number. If when you subtracted them, you got your whole entire interval was positive and didn't include zero, then you'd say that, oh, P1 must be larger than P2. If you include zero, then it could, it could be zero. Personally, I feel like that's ridiculously, it's not useful in any real sense of the word. Maybe there's some use for it out there, but I had deleted it from your homeworks, and it's not going to be on the exam.
Yay.
So, sorry if you did it already. I think a couple of you guys did.
Yes, I did.
Sorry.
Yeah, whatever.
Okay.
Who cares?
Right. So now,
More practice.
we're going to move on to something we are going to cover. Alyssa, go ahead.
What if we want to compare the means of two samples, experimental versus control group? Each sample has its own X bar and mu. Cars with gas additive versus cars without. H naught equals
Is
mu1 equals mu2. So for null hypothesis test, mu2 minus
mu1 minus mu2?
what?
mu1 minus mu2?
I can't see.
Equals zero?
Equals 0.
Yep, that's right.
H1
Is one of these. It's either mu1 is not equal to mu2, mu1 is greater than mu2, or mu1 is less than mu2. Good?
You too.
Thanks. Good. So this is for two sample means, right? Our null hypothesis is that the means are the same. mu1 equals mu2. H1 would be that they differ in some way. There are a couple rules about it. First of all, they need to be simple random samples. If they're not random samples, then your data is garbage. 2, the samples must be independent of each other. So you take a sample, and then you randomly select another sample. They have nothing to do with each other. And then 2, the sample sizes should be either larger than 30 or normally distributed. Pretty much, I'm always going to give you samples. So in other words, if I give you sample size less than 30, I need to say, assume the variable is normally distributed. And you'll see that a lot on the test. All right, so everything else is the same, except for this is your test stat. Your x bar 1 minus your x bar 2 minus mu1 minus mu2. But we assume that that's 0, so we assume that they're the same, so that should be 0. Divided by the standard deviation of two samples. The square root of S1 squared over N1 plus S2 squared over N2. Where the degrees of freedom, your textbook uses the smaller n. So you have two samples, right? You have two n's. Your textbook takes the smaller sample, the smaller n, and subtracts 1 and uses that for degrees of freedom. All right, so that's what you'll do in your homework. And you should all have that marked in here on your little yellow sheet, right, 100 degrees of freedom. Instead of that big, giant, crazy calculation that's there instead. So why don't you guys take another 10 minutes to do quiz problem number 2? Does that seem reasonable?